Hello, everybody. How are you? Woo! Yeah, we have 10 minutes and less than 10 minutes already. So let's get started. Okay. It doesn't work. Okay. Okay, so sorry for that. Technical problems as well, as always. Hello, everybody, again. My name is Gil, and what I'm going to talk about a little bit is your typical web page design. So your designer in the company comes to you and gives you some web page. And you're a developer, a front-end developer. And let's drill down in how you will probably want to work with that design. So first of all, you will break it into some components, okay? Literally, you'll just write components and all the child components that you have. Then, you will break it really into component implementation. But how would you build that page? Is it really necessary for us to use a library or a framework like Angular, React, Vue, whatever? What if I'll tell you that you can teach the browser how to create or how to use real or new elements? If you can do that, you'll gain a lot of strength. So this is where our journey begins. A little bit about myself before we drill down. I'm Gil Fink. I'm Sparks's CEO, even though it's written that I'm coming from Taboola. Taboola is one of my customers, and they asked me to be on stage and talk with you. So you can talk with me after the session in Taboola's booth. I'm a Microsoft MVP in the last 8 years. I wrote a book, Pro Single-Page Application Development. I wrote a few official courses that are learned in Microsoft Learning Centers, like, for example, HTML5 programming. And I'm co-organizer of GDG Rishon, a meetup, and Angular App Conference. So what we are going to do in the next 8 minutes. So I'll start talking about Web Component APIs, and then I'll drill down into Stencil. What is Stencil? So we all know the Web Components API, okay? They are a natively support standard to create your own JavaScript components. They're usable, composable, expressive, include semantics, and everything. As you know, we have 4 different APIs: templates, imports, shadow DOM, and custom elements. And this session, I'm going to talk about custom elements. So for example, if I want to write my own custom element, I'll start with some template, probably. And then I'll create my element. If I want to add shadow DOM, then I will have to craft it. And if I want to use the template from the previous slide, I will need to inject it or craft it again by myself. And custom elements have lifecycle events. So I need to wire things like event handlers and etc. I'll need to hook to those lifecycle events. And last but not least, I need to say to the browser, hey, this is a custom element, please define it. And the output will be some collapsible panel. And you can find this demo in my GitHub. Later on, you can go in and play with it. But there is a problem here that is underneath. We have a Catholic wedding with libraries and frameworks. For example, if you work in a company and you build your infrastructure, you'll probably choose a library or a framework like Angular, Vue. But if a different team want to use another framework, we have a problem because all the infrastructure is built upon one framework. What can we do? So, of course, custom elements can help you, very, very help you, because they're not related to any library or framework, and they encapsulate all their functionality in CSS, and you can use custom elements with all the frameworks. Okay, so if you use Vue or Angular or React, then they can use custom elements, okay? So if you want to build infrastructure to your company, you'll probably want to use custom elements. But there are problems with custom elements. First of all, we are so related, or we are so fun about runtime frameworks, so libraries, okay? They give you goodies like virtual DOM, data binding, performance. If you are using or you want to use custom elements, then you need to craft everything by yourself. More than that, the syntax of custom elements is a little bit verbose. And again, I need to craft everything by myself. And that's a problem. Another problem is that custom elements isn't supported in a few browsers, so you need to create your custom element with polyfills. So is there a better way? What if I can tell you that you can solve all those problems in one place? This is where Stencil comes into place. What is Stencil? Stencil is a compiler. A new compiler. It was shipped 1.5 months ago, and it compiles your code into custom elements. But it adds to those custom elements a lot of goodies like, for example, virtual DOM and reactivity. And you write things in Stencil using CSS and TypeScript. So if you're familiar with those concepts, you are ready to go. Who is creating that compiler? So the Ionic team, the Ionic framework team, created Stencil, and all Ionic core is currently replaced to Stencil. So if you want to get started with Stencil, what you are going to do is, first of all, clone the Stencil component starter, and npm install and run, and you have your first component. How it looks like. So the component looks like this. You have decorators, like in Angular, that decorates the component and tells Stencil how to create your component for you. More than that, you have a render function that uses JSX underneath that enables you to create or render your component. When you do that, when you create your Stencil component, then you will compile that component into regular custom elements. Design time, baby. Really design time. Everything is in design time. It's not in runtime at all. So if I want to replace the collapsible panel from the first slides, then I will do something like this. I will write a Stencil component that includes the decorator, for example, for a component. If I want to add shadow DOM, all I need to do is tell Stencil shadow semicolons true, and I'm ready to go. I use decorators to express properties and state elements inside of my compiler. And then I use JSX to explain to the compiler how it should render the component, and that's all. Later on, I'll compile the component, and I'll get the same component that we saw earlier, but right now using Stencil compiler. But Stencil has a lot of advantages. Underneath it, every component has its own virtual DOM. All the components are reactive, meaning that if a property changes, I don't need to wire anything. The Stencil render function will run again, and if the state does that, it will be the same. It includes lazy loading for the components. It has very good performance, because underneath it uses preact, and it's similar to Fiber in React, if you heard about that. So how Stencil solve the problem of custom elements? Everything is in the build process. Okay, you build your infrastructure using Stencil, you build the components, and then you ship those. And all the teams in your company will be able to use those components. Either if you're choosing React, Angular, Vue, because it's custom elements, every team is enabled to use your infrastructure. And you don't need to pick any library or framework. So let's summarize. Web Component Standard is very powerful. After my talk, there is another talk that will explain a little bit about custom elements in more deep, I hope. And Stencil Compiler just removes all the pain from using custom elements. It includes the polyfills, a lot of goodies like virtual DOM and reactivity, and et cetera. There are resources. The slide deck is going to be online in a few minutes after the session. Go to stenciljs.com. This is the website of Stencil. You can follow me on Twitter @GilFink, and you can go to the booth of Tabula booth and meet me there. And with that, I want to conclude with one thing. Start using the web platform as it is, okay? You don't need frameworks and libraries. Use those, but if you can, create reusable components using either custom elements or Stencil. Thank you.